Nidhi Hartimath of CSA department from KLEIT Institute of Technology. My project title is on lung cancer detection. The objective of this project is to develop an image classification system for lung cancer detection using CNN model, that is convolutional neural network. It classifies the lung images, that is CT scan, into benign, malignant and normal. The libraries used are TensorFlow and Keras, NumPy, Pandas, Matplotlib, OpenCV and many more. Now coming to the code. First, here I am importing drive from Google Colab. It will allow us to interact with our drive. It will allow us to interact with our drive directly within the Colab notebook. Then next, in this code, I am installing the required libraries, that are TensorFlow, Keras, NumPy, Pandas, Matplotlib and many more. Here in this code snippet, I am installing Keras because we are fetching the dataset from Kaggle. So to fetch the dataset from Kaggle, we have to install the Kaggle. Then it makes a Kaggle directory in the Colab, which provides the right for our Colab to communicate with the Kaggle. Then I am downloading the Kaggle dataset with Kaggle dataset. Then I am unzipping the downloaded dataset. In this code snippet, I am importing NumPy for linear algebra and Pandas for data processing. And I will list and display the paths of all files inside a specific directory. In this, OS work is used for sequence of tuple for each directories. In next code snippet, the directory name and the file name. The directory name contains the path of the current directory and file name contains the list of the file names. In this code snippet, we are importing the required libraries. We are importing Pandas for data manipulation and analysis. We are importing NumPy for providing support for large multi-dimensional arrays. And we are importing Keras for deep learning API in TensorFlow used for building neural networks. And we are importing warnings, which hides the unnecessary warning messages. These are all the required libraries. In this code snippet, this is directory definition. The benign directory, it is the list of directory path of the benign. In malignant directory, it is the list containing the directory path of malignant, and normal directory, it is the list containing the directory path of normal. Then initialization, the file path is used to store the each image path. The labels are used to store the each image labels. Then the directory list, it contains the benign directory, malignant directory and the normal directory. The class label contains the labels of benign, malignant and normal. Then file path and label collection. The enumerate function is used to iterate over each category's directory list. The file path append the parts of the file from the file path. The label.append appends the class labels from the label. Then creating the data frame. Here there are two data frames, that is F series and L series. The F series contains the file paths and L series contains the labels. We will concatenate both of the series to create a Panda data frame, which is named as the lung_df. Then we are printing the lung_df.head. It is used to print the first few rows of the data frame to preview the data. Then we are printing the lung_df labels. It is used for the occurrence of the each label. Here we can see the malignant is 561, normal has occurred 416 times and benign has occurred 120 times. Then lung_df.shape is used for the dimensions of the data frame. After this, we are splitting the data frame into training, validation and testing the sets. After training, validation and testing the sets, we are printing the dimensions of the training, validation and testing data sets. Here the output is 613,2, 330,2, 154,2, 767,2. Then here we are pre-processing the models. In pre-processing we are using image data generator. Then we are then in training section, X column contains the file paths and Y column contains the labels. The target size is 244,244 and the color mode is RGB. The color class mode is categorical, that is it is used for sequential model, and the batch size is 8 and shuffle equals to false because it will not shuffle the data. Then the same is done for testing and validation. Here we can see that the validated image files belonging to the three classes. Then we are extracting the class label identified by the image data generator and we are printing the classes that are malignant, normal and benign. In this code snippet, we are visualizing a batch of images from the image generator. We are defining a function called as showKeyImages. It is used for grid format using the matplotlib. Then images label equals to next image gen. It is used to get a sample of batch from the generator. Then if length is less than 25, r equals to length, else r equals to 25. This part of the code tells that the maximum image that can be displayed are 25. Then image equals to image I plus 1 by 2. It scales the images between 0 and 1. Then image equals to np dot argument max. It is used for index of the class label. Then we are showing the images of normal, malignant and benign. Then we are building the model. To build the model, we are using keras.model.sequential. This model architecture contains Convo 2D, batch normalization, max pool 2D. These are the model architecture which are used for image classification. Then this part of the code helps the model classify images into one of the three categories while minimizing fitting and optimization. Then we are doing the model compilation. In model compilation, this code compiles the model using the categorical cross entropy, which is appropriate for multi-class classification. It uses the stochastic gradient descent SGD optimizer with a learning rate of 0.001 and tracks the accuracy as a performance matrix during the training. Then we are summarizing the model, that is overview of the model architecture using the model.summary. In this code snippet, we are visualizing the architecture of a Keras model using keras.util.plot model. It shows the architecture of the Keras model. After this, we are training the model. For training the model, we are using epochs. The epoch is the number of complete passes through the entire training data set. Here we are given epoch equals to 40, which means that the model will go through the entire data set 40 times. Then we are measuring the performance of the trained model on a specific data set. Then we are saving the model using model.save and add the Keras extension to the file name. Then we are making predictions on the tested data set using the trained model. After this, we are plotting the accuracy of the model during training and validation over each epoch. We can see that the model's accuracy has increased over each epoch. In this code, we are plotting the loss of the model during training and validation over each epoch. We can see that the loss of the model has decreased over each epoch. Then we will evaluate the performance of a trained model using classification matrix, classification report and accuracy score. For this, we are using sklearn.matrix and we are importing the confusion matrix and accuracy score. here we are setting y test to the expected output, and we are printing the accuracy of the model. This model's accuracy is 97%. Then we are generating and visualize a confusion matrix for evaluating the performance of the classification model. And then we are printing. Here x label is predicted and y label is actual. This is the confusion matrix. This is the predicted one, and this is the actual one. Then we are loading. We will load and display the images using matplotlib, TensorFlow and Keras. Here we are defining a function called as show images. Then the image path takes the image path as the input from the user, and then it will display the image. If exception occurs, then it will print as file not found. Then we are processing the image using image.loadImage. Then we are making the prediction using the model. Then we are printing the prediction result, that is benign, malignant or normal. Here you can see we have given the input as the images path, and the output is image with its label. Now we are deploying the total overall code to the Streamlit app by installing the pip install Streamlit. Here I am writing the entire code into the app.py. And I will run the app.py in the local terminal. This is the output you will get. This is the interface for lung cancer detection. We are uploading the image. This is the output. We have uploaded the image here, and it is predicting the image as benign. The prediction is correct. We can upload another image. It is predicted the image as normal. Then the applications of this project is, it is used in medical field for early lung cancer detection, clinical research and trials, and etc. Thank you.